Find the inverse of the following matrix of order 3 by 3. You know the definition of A inverse. It is 1 by determinant A into adjoint A. Let us first work out the value of determinant A. That is determinant 1, minus 1, 2 are the elements of first row, 0, 2, minus 3 second row, and 3, minus 2, 4 are the elements of the third row. Now let us work it out, the value of determinant along C1. So expand. Why particularly along C1? Because at least one 0 is there. It will be convenient, though you may do it with R1 or whatever you like. Expand along C1. So you get 1 time, the value of determinant is 1 time, delete the row and column through 1, you get 2 minus 3, okay, let me write 2 minus 3 minus 2, 4, and then minus 0 time will remain 0, and plus 3 times, delete the row and column through 3, and you will get, see, minus 1, 2, and 2 minus 3. So if you work it out, you get 1 time C8 and minus 6 and 0, and 3 times you get 3, there is 3 minus 4. So you get 8 minus 6, 8 minus 6 is 2, and plus 3 times 3 minus 4 is minus 1. So finally you get 2 minus 3, that is minus 1. So the value of determinant A is minus 1. Please take a note of it. And now let us find out adjoint A. Adjoint A is defined as transpose of a matrix obtained by replacing each element of A by the corresponding cofactors. That is C11, C12, C13, C21, C22, C23, C31, C32, C33. Work out and take the transpose. And to work out, we also impose the signs plus, minus, plus, minus, plus, minus, plus, minus, plus. So to find the cofactor of any element, you delete the row and column through it, work out the remaining determinant, and with a proper sign which have been mentioned. Let me show you some of them here. Say C11. What will be C11? It will be with the plus sign, delete the row and column through 1, 1, which happens to be 1 here. So you left with the determinant of second order 2 minus 3 minus 2, 4. If you work out, you get 8, outside is already plus, 8 and minus plus 6. So you get 8 minus 6, that is 2. So the value of C11 is 2. And now find out C12. For C12, it will be, with negative sign, and delete the row and column through 1, 2, you left with 0, negative 3, and 3, 4. So work out, you get negative times 0 and minus plus 9, so you will get minus 9. Minus 9 will be the value of C12. And now let me work out one more, say C13. C13, of course, will be with plus sign, delete the row and column through 2, you get determinant 0, 2, 3 minus 2. If you work out, you get 0 and minus 6, so minus 6. Similarly, you try yourself rest of the cofactors, and let me write here that adjoint A is transpose of, we have already worked out the cofactors in the first row as 2, minus 9, minus 6, and rest of them you find carefully, keeping in mind the signs also, and you will get 0, minus 2, minus 1, minus 1, 3, 2. But remember, when you write the adjoint A here, don't forget to take the transpose of it. When you take the transpose of it, the elements of the first row, that is 2 minus 9, 6, will go to the first column, 2 minus 9 minus 6. Elements of the second row, that is 0 minus 2 minus 1, you write in the second column, and that of the third row minus 1, 3, 2, you write in the third column. So now we have already got adjoint A. So what about inverse? A inverse is defined as 1 by determinant A into adjoint A. The value of determinant A you worked out as negative 1. So 1 upon negative 1 times the value of this thing adjoint A is 2, 0, minus 1, minus 9, minus 2, 3, and minus 6, minus 1, 2. And because outside it is 1 upon minus 1 means only negative sign. So just change the signs and you get A inverse as matrix. Make a change of sign throughout. You get 2, 0, negative 1, 9, 2, negative 3, 6, 1, negative 2. Please check. A inverse is negative. A inverse, when you change the sign, even 2 also, the sign is to be changed. So minus 2, 0, 1, minus 2, 0, 1, and 9, 2, minus 3, and 6, 1, minus 2. Yes, that is the value of A inverse. Find the inverse of the following matrix. You know the definition of A inverse. A inverse is defined as 1 by determinant A into adjoint A. Let us work out the value of determinant A. That is, determinant is 1, 0, 0, 0, 0 here in the first column also, and rest of the elements are cos alpha, sin alpha minus cos alpha. So there being 2 zeros in the first column, first row as well as first column. So anyway, let us expand it along row 1. So you get 1 time cos alpha into minus cos alpha minus cos square alpha minus sin alpha sin square alpha. Minus you take common, you get cos square alpha plus sin square alpha, which is trigonometrically 1. So what is finally the value of determinant A? Minus 1. Just keep it with you. That is, determinant A is minus 1. And now let us work out adjoint A. Adjoint A is defined as transpose of a matrix obtained by replacing each element by the corresponding cofactor. That is C11, C12, C13, C21, C22, C23, C31, C32, C33. With how do you work out any cofactor? Delete the row and column through that particular element, and rest of the determinant you work out with a proper sign to be imposed, and you know the corresponding proper signs: plus, minus, plus, minus, plus, minus, plus, minus, plus. You know all this. So now let me work out just one or two of them. Say for example C11. Delete the row and column, it will be outside plus sign. Delete the row and column through A11, that is 1, and you get cos alpha, sin alpha minus cos alpha. If you work it out, you will get minus cos square alpha minus sin square alpha. Taking minus common, you get cos square alpha plus sin square alpha, which is 1. So the value of C11 is minus 1. Let me also work out C12, and it will be with C12 will be with negative sign. So it will be negative times, delete the row and column through C12, that is 0, and you get 0, 0, sin alpha and minus cos alpha. Obviously it is 0. Similarly, I leave for you to try the rest of the cofactors, and you get the value of adjoint A equal to, adjoint A is equal to transpose of, you know, we have already worked out the cofactors in the first row, negative 1, 0, 0, and similarly the rest of them you can work out yourself as 0, negative cos alpha, negative sin alpha, 0, negative sin alpha, cos alpha. Don't forget to take the transpose. So adjoint A for the given matrix finally elements of the first row, negative 1, 0, 0, you write in the first column. That of the second row, 0, minus cos alpha, minus sin alpha, you write in the second column. And element of the third row, 0, minus sin alpha, cos alpha, you write in the third column. So we have already got now adjoint A. So what is the value of A inverse? A inverse is 1 upon determinant A into adjoint A. And what is the value of determinant A we worked out? Negative 1. So 1 upon negative 1 into, and the value of adjoint A you worked out as negative 1, 0, 0. 0, negative cos alpha, negative sin alpha, and 0, negative sin alpha, cos alpha. Now outside it being negative 1, so it's better you change all the signs. So you get finally the value of A inverse as 1, 0, 0. 0, cos alpha, sin alpha are the elements in the second row. And in the third row you have 0, sin alpha, and minus cos alpha. So that is the required value of A inverse.